Hi everyone, in this video we're going to be looking through example 1 under the standardized statistic examples. And so this has lots of parts to it, so we're going to talk through what's going on here. So what the question asks us to do right here is we're going to label our distribution. So we're thinking here chance models. We've got some nice chance models here. We're going to label them with the values of the statistics along the horizontal, so like the x. We're going to label the distribution with the standardized statistic values, identify if the standardized statistic is positive or negative or zero, and if we should call it a t-score or z-score, and then find the actual value. So what we're going to do here is we're going to talk a little bit about the kind of like best case scenario of this. And so we have this chance model. And every time we've seen a chance model so far, it's had this shape, right? And inside this shape were a bunch of dots. It wasn't this perfect shape, but it was pretty good. And each dot represented, if it was categorical, a proportion. So a little sample proportion, okay? Now, we know where the middle is supposed to be. It's where our null hypothesis told us, right? Whatever number that is, that's your middle. But what really is interesting here is that this shape is completely determined by the middle and the standard deviation that we talked about earlier. And what do I mean by that? Well, what ends up happening, and this is not perfect because we're simulating and it's not the full picture, but under this, the way you should think about it is if we were to be able to simulate this forever, we would end up getting this nice shape here. And the idea is the middle, we know where it is, predict it, boom. And we know how it's spread out. And the way it's spread out is you start at the middle, and then you'll have the same proportion of p-hats, one standard deviation to the right. So what am I doing here? I'm taking my middle, I'm adding one standard deviation, which is 0.03. And every single time we have a chance model like this, the same percent of our samples will be in this little sliver between the mean and the first one standard deviation up. Every time we do this, the same percent of these little p-hats will be between the middle and the first two standard deviations. In fact, if we were to expand this a little bit, if we collect all of the samples in here in our chance model from -2 standard deviations all the way up through +2, we should expect 95% of all of our samples to sit in that little zone. So right in here, and I'm not saying this one example, I'm saying every example we do this way, every single time we've got this categorical data, if we make a chance model, we should expect that 95% of all the little simulated p-hats will sit between -2 standard deviations and +2. It's an amazing fact that this works. But it's awesome because all you need to do to get the full complete picture is know where's the middle and what's the standard deviation. Because you can just do what I did here and construct the rest. 0.4 is the middle. Go up by 0.03. That's there. Do it again. That's there. Okay, go down 1. I subtract. Go down 1, I subtract. So here's the idea. If 95% of your simulated p-hats are between these two values, and your number that you got is outside those, well, what can you say? You can say that the chance that that should happen is 5% or less. Well, what were we saying about that? We were saying, oh, okay, well, that just means that's crazy. It's not going to fit the null hypothesis. Throw out the null hypothesis. That's exactly what the standardized statistic is doing. The standardized statistic is saying, where are you on this picture? How many standard deviations are you away from the middle? Not what's your fixed distance. How many standard deviations are you away? And why do we do that? We do that because this calculation works for all of these scenarios. It doesn't matter what your scenario is. It doesn't matter if it's Buzz and Doris. It doesn't matter if it's Yummy's the candy bar. It doesn't matter what other random things I've thrown at you in terms of problems. The 95% of your simulated statistics are going to sit between -2 standard deviations and +2 every time. So then all you have to do is figure out if your statistic falls outside of that range. And if it does, alternative yay, null, no. If it doesn't, we say null, okay, alternative, Boom, z-score. So I'm going to do that z-score for you here. We're going to take our statistic, 0.352. We're going to subtract away the mean, 0.4, middle. We're going to divide by the standard deviation. We get this number -1.6 here. What does that mean? It means that your statistic is 1 and a little more than a half standard deviations away from the middle, but to the left. So all this says is to the left. But you didn't really need the z-score for that, right? Just look at the picture. 35% is right about here. What does that look like to you? It looks like 1/2 and a little bit more. Well, that's still in this middle 95% chunk. So, okay, close enough. I think the null hypothesis is probably fine. Boom, done. So let's try B and see the same idea. So the same idea still works for means. So I see X bars in here. I'm going to use a t-score. But remember, these are just names for the different ideas. It's basically the same. Okay, what am I saying? The middle is where the null is, and most, 95%, if we're being a little bit more technical, but most of the statistics that I simulate, right, will be between -2 and +2 standard deviations. These two, okay? So the z-score will tell me how many standard deviations I'm actually away if I look at my statistic. If I'm within 2 on either side, we're going to say, yeah, you're good. Null sounds fine. If we're outside 2, we're going to say, no to this null. I like the alternative. So 456.2, that's our statistic. Don't even calculate anything yet. Go find it. Right about here. That's well within the middle, so I bet my z-score is going to be pretty small because I'm not very far. I'm not even 1 full standard deviation away. Well, let's try it. We got the statistic. We're minusing. Whoops. We got the statistic. We're subtracting the mean. So to tell me how far away they are from each other, we divide by the standard deviation. We get 0.775. It's positive, which means I went right. Okay, that works. And it's less than 1. Oh yeah, because I really didn't even go that far. This number is small, so we say null is good. That's it. Every single one of these, same idea. So what do I want you to do? I want you to practice setting up these values, middle, add standard deviations, subtract them, so you can get an idea of where two apart is. I want you to always be able to go middle and 2 down, 2 up. Go find your statistic on here. See if you think it fits within the first 2 standard deviations. Do the calculation. Make sure this matches. This number says your statistic is only 1.52 standard deviations away. And so what we're thinking here is we're just going to think of standard deviations like steps. We're defining a way to step away from the middle such that no matter what problem we ever look at, each step will cover the same percent of the picture, the same percent of all the samples. So no matter what I'm talking about, if I tell you I'm 1 standard deviation above, you know the percentage of samples that you're bigger than. You know where you are in this picture. So that's the idea of this. So keep working through these. Try to see if you can get through these. Make sure you can get the same numbers as I can. Make sure you're opening up the not solutions version, trying to fill this out, and then going to the solutions version to check, and then the video as well.